This video was sponsored by Notion. Let's say Alice and Bob go into the casino to play some roulette with only one objective in mind: win $100. But they both have different strategies and different starting amounts. Bob only has $100 to begin, so he's going to keep it short. He will bet $100 on red once. If he loses, he's done. He lost his 100. And if he wins, he gets $100. Red pays 1-1. So he walks away because he hit his goal. He's done. Alice, on the other hand, comes in with $10,000, but she's only going to bet $1 on red over and over until she's either up $100 or she loses everything. She won't stop until one of those happens. And remember, red only pays out whatever you bet, so she needs 100 more wins than losses before everything is gone. And note, there are 18 out of 38 spots that are red, so that's roughly a 47.4% chance any individual spin lands red. Okay, now the question is, who has the better chance of walking out of this casino having made $100? And before you attempt to prove this on your own, just note the proof itself is not obvious or meant for a video like this, but I will provide a link below for more detail. Okay, here we go. Since there are 18 out of 38 spots that are red, that means Bob simply has a roughly 47.4% chance of getting his $100 and a 52.6% chance of losing everything. He's only doing one bet, so the math is easy. Alice, on the other hand, ready for this, has a 0.00265% chance of winning that 100. As in, it is almost certain she's losing all 10,000 before she makes just 100. If you didn't get that, it's okay, you got one more try. Because here comes the richest man in the universe, Carlos. He's going to do the exact same thing as Alice. He's going to bet $1 at a time until he wins 100 or loses everything. But he's starting with $100 trillion. So he's just got to get 100 more wins than losses before he gets 100 trillion losses over wins. So what are the odds he walks away reaching his $100 goal? Or how much more likely is he to win compared to Alice? Since, he's doing the same thing but has more opportunity to win. Well, guess what? He has a 0.00265% chance of winning $100. Again, it is almost certain he will lose 100 trillion before he makes 100. He is no better off than Alice. Now, if that bugs some of you, you're right, these numbers are not the same. Carlos has to have better odds, and he does. But the difference is so small, I had to use a high precision calculator just to find it. And here it is. So, they basically have the same chance of winning $100. Now, the equation to figure this out that tells you the odds of going up some amount given your starting bankroll is this here. And again, how it is derived is not obvious, not for this video, but I'll put a link to an MIT lecture down below where the professor goes through the proof. So for the people who do this strategy in the casino, bet the same amount over and over, this equation tells you everything you need to know. Here, let's make a real scenario where you have 20 units to play with, pretty common, as in like you're playing a $10 roulette table and you have a total of 200 to play with. Or it could be a $100 table starting with 2,000, whatever. You simply have 20 times the minimum allowed bet. Now, if your strategy is, I will bet $10 on red or black over and over until I make M dollars or until I've lost all 200, then here's the probability E of succeeding given different values of M. So you're actually more than likely to win if you tell yourself, hey, I'm going to stop once I'm up $50 or anything less. So the important thing to note here is that how you play absolutely affects what your odds are of walking out of that casino with more money than you started with. A common phrase you hear is the house always wins, but that's not really true. Yes, it's true in the long run, casinos will make money, but anyone can walk into the casino and have a higher chance of making money than losing money. In fact, you can make the probability of winning money really anything you want between 0 and 100%, not inclusive. Sorry, it can't be 100. But if you want a 99% chance of walking out with $100 or even $1,000, you can make that happen. The thing is, the higher the probability, the more money you stand to risk in general. I mean, we saw that wasn't even the case with Alice and Bob, but in general, if you want a 99% chance of walking out of that casino with $1,000, let's say, then you need a lot more than $1,000. So you stand to risk more, but again, you can make the probability whatever you want for the most part. But within this fact is where the casinos make money, because that risk always outweighs what you stand to make in the long run. If everyone watching this video went to a casino and tried this strategy, let's say, to make $30 and then walk out if you succeed, then most of you, over 70%, are going to win $30. But the 30% of you who lose will lose $200, over 6 times more. And that total loss, looking at everyone's losses, doesn't just cancel out the total wins, it exceeds it. Add up all the wins and losses, and the losses will always be greater. That's why the house wins in the long run when looking at everyone. Individually, not necessarily the case. So again, the lesson here is how you play and what games you play absolutely has an effect on your odds of walking out of that casino with more money than you started with, or less, and how much. But there is one thing in the casino, one mathematical concept, that you cannot change. You cannot outrun, you cannot avoid this, unless you're cheating. But in general, you cannot change this. I'm going to explain what that is after thanking the sponsor of this video, Notion. Notion is an amazing productivity tool that you can use to stay organized, manage tasks, take notes, and much more, whether just for yourself or for any kind of team. So whether you're wanting to be more productive at school or you're running a company, Notion has everything you'll need. You need to make a weekly agenda or an entire calendar? Notion makes it real simple to add and check off events and projects as needed. Want to just take notes for class? Just open a new page and start typing. Or if you're in a business meeting, all notes can be taken and saved in Notion, so everyone is sourcing from the same place. You can start conversations and leave comments on collaborative projects, so no digging through endless emails or scrolling through group chats to see what was asked when. You can even publish pages to the web, so if you're just thinking about starting a business, even by yourself, Notion is a great tool. If you have a bigger business, you can make galleries to organize who is on the team, their roles, location, and much more. And different permissions can be granted to different people based on their role and how you'd like to structure the business hierarchy. What I really love about this platform is just how incredibly customizable it is. You can add images, you can color code, create columns, rows, and sections as needed. You can nest pages as much as you'd like, so no searching endlessly for tasks or projects you're working on. You can really organize your workflow as professionally as you want to. So if you'd like to save yourself time and increase your productivity with Notion, then just click the link in the description below to sign up today. Okay, now getting back to the casino, the mathematical thing you cannot avoid or change unless you're cheating is your expected losses, otherwise known as the house edge. Now, the expected value or weighted average can be thought of as what your running average will approach after many samples of something. Like the expected value of a single fair die is 3.5, because yes, it's the average of the numbers, but also if you rolled that die over and over, keeping track of the running average, well, it's going to bounce around in an almost unpredictable way, but it will for sure approach 3.5 over time. So thinking in terms of expected values or the house edge, every single casino game can be simplified to a coin toss game. Let's say we have a game where you flip a fair coin, and if it lands heads, you get $1. If it lands tails, you lose $1. You give it to, quote, the house, the casino, whatever. This would be considered a completely fair game, as in no one has an edge, and your expected loss is 0. If you played this game over and over and kept track of your winnings versus number of tosses, that Y value would just randomly bounce around 0. Sometimes you're up, sometimes down, but the best fit line you can think of would have a slope of 0. However, if we change the game, where now if it's heads you win 90 cents and tails you lose $1, this is now a biased game where the house has an edge. That edge is 5%, which is calculated from the fact that half the time you win 90 cents and half the time you lose $1. So that comes out to an expected loss of 5 cents per bet, which is a loss of 5% of the dollar that you stand to lose, your bet essentially. So this game has a house edge of 5%, and if we played over and over, then we can expect our net profit over time to look something like this. While chaotic, it would dance around, instead of a line with no slope, one that looks like this. And if we kept playing and zooming out, the actual profit would look more and more like that best fit line. That line has the equation y equals negative 0.05x. There we can see that 5% number. And we can use this to make predictions that are more accurate as a percentage as time goes on. After you've played through 800 tosses, basically wagering $800 in total, I expect you'll have lost about $40, 5% of 800. In this simulation I ran, the actual loss was $46.70, so pretty close. But that expected loss percentage, 5%, tells us roughly what's going to happen in the long run. If there was another game offered where heads means you win 97 cents and tails you still lose the dollar, the graph would look like this. Here you can see the best fit line of now y equals negative 0.015x from the house edge now being 1.5%. After 800 bets, just take 1.5% of that, and I assume you'll have lost $12, which is close to the $15.94 lost in this simulation. Won't always be that accurate, as you can obviously see, but the point is, over time your actual losses will be fairly predictable. Now, if you were forced to play one of these two games, which one would you choose? Well, unless you're not a fan of money, should be pretty obvious that this one is more in your favor. All things equal, except you win more when it's heads. But there are several people who have and will choose this game over the other one. Well, sort of, without knowing it, because this right here is pretty much roulette, while this game is craps. The coin flip game and the respective casino games you see here are just about identical in terms of the expected losses or the house edge. To be exact, Double Zero Roulette has a house edge of 5.26%, no matter where you bet, red, black, even, odd, or individual numbers, compared to the 5% house edge of that respective coin flip game. Craps has a house edge of 1.41% when you're betting on the pass line, compared to the 1.5% of the coin flip game above. But just like before, we can accurately predict our future with these numbers, at least in the long run. The math is no different. If you're betting $10 at the roulette table and play for 500 spins, you'll have wagered $5,000 in total. House edge is 5.26%, so just multiply that by 5,000, and you can expect to have lost $263. And if you did the same thing with craps, $10 per bet for 500 bets, same thing with $5,000 wagered in total, and at a house edge of 1.41%, you can expect to lose $70.50. And you can do this for any game. When you look at the house edge for anything in the casino, it's simply telling you you're expected to lose that percent of every bet. Multiply that percentage by how much money you've bet in total, and over time that prediction is going to be more and more accurate. And you might be asking, what about something like roulette, for example, where you bet on an individual number and you can get 35 times your bet if that hits, whereas the coin flip game only had a 1-to-1 payout? Well, it doesn't matter. There are 38 numbers in total, so you have a 1 out of 38 chance of winning 35 times your bet, and a 37 out of 38 chance of losing 1 times your original bet. Do the math and look at that, there's still a 5.26% house edge. So if you're only betting $1 on red, I bet only $1 on 21 to go for that 35 times payout, and then someone else plays the coin flip game with these rules, after hundreds or maybe thousands of rounds, each person is going to have lost just about the same amount of money, because through the lens of expected values, these are all the exact same game. And I know people go to the casino often just for fun, and roulette is obviously much easier than craps or blackjack, but if you are genuinely looking to keep your losses to a minimum, or wins to a maximum, and you're debating between like roulette, craps, baccarat, or blackjack, just ask yourself, which of these coin flip games would you rather play? Because it's all the same in the long run. And yes, as you can see, blackjack is the best game to play in the casino. if you know basic strategy and have favorable rules like blackjack pays 3-2, or you're counting. And since I love playing craps, I will mention for any craps players who like placing a variety of bets, if you are playing anything except the pass line or don't pass line and odds, then in the long run, you're losing more money than if you just stuck with those basic bets. I know that'll upset some people, but it's true. But the most important piece of advice I can give if you're going to walk into the casino, and this is backed by tons of scientific research, is that never walk away from the table if you're on a heater. Good luck.